Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon, everyone, and welcome. My name is Kim Ricketts, and I'm here to introduce and welcome Kevin Kelly, who is visiting us as part of the Microsoft Research Visiting Speaker Series. Kevin is here today to discuss his new book, What Technology Wants. Technology as a whole is not just a jumble of wires and metal, but a living, evolving organism that has its own needs and tendencies. By listening to what technology wants, we can better prepare ourselves and our children for the inevitable technologies to come. Kevin Kelly has helped launch Wired magazine and was its executive editor for 7 years. He has written for the New York Times, the Wall Street Journal, and The Economist, and his previous books include Out of Control and the best-selling New Rules for a New Economy. Please join me in welcoming Kevin Kelly to Microsoft.
Thank you. It's a great pleasure to be here. Actually, I haven't been in this building before, but I have been to Microsoft Research in times previous. It's great to be among people who are all smarter than me, so I'm looking forward to some great questions. I'm here to talk about my book, What Technology Wants, although I'm also very eager and happy to talk about other things, wired-like stuff, because what this book does is it basically kind of steps back and takes a look at the long-term trends in technology, and looking long meaning like hundreds of years, whatever. And that may not be as useful to everybody here. The wired view is sort of like the next 6 months, the next couple of years, the next few years, and I'm, again, happy to talk about that as well. But let me just give you a sense of what this book is about. I take the idea that, okay, all of us collectively are engaged in making all this kind of stuff. Every day we're tweaking this, we're creating that, we're making these large systems, and we're filling our world with a lot of constructed things that originated in our minds. As far as we can see, as far as I can see right now, almost everything, in my view, has been made by us. And we're making more of it. And the question that I have been asking myself is, well, what is the stuff that we're making? What is it in the realm of the cosmos? What does it mean? Is it good? Should we make more of it? How should we feel about it? And when something new comes along, should we embrace it or question it? And that's sort of the framework. And as I looked at that, I realized that there really wasn't a good theory of technology. There's no framework. We have the theory of natural selection. We have a theory about evolution, which gives us kind of a framework to understand the natural world, but we don't really have a good theory about technology. The kind of reigning theory was, oh, it's a product of our minds, and it's whatever we think it is. And that didn't really ring true to me as I looked at the history of it. And I think the premise that I began to looking at this was to realize that while we might make, the first technology we made was a little kind of a stone hammer, stone axe, and a handheld thing, and one person could make it. But if you think about the mouse, the little mice that Microsoft makes, it's about the same size, fits in their hand the same way. But this is an artifact that might require thousands of other technologies to create. And nobody here could make a mouse. In fact, even us collectively could probably not create it. So it's an embedded thing. It's actually a network and cluster of ideas and technologies. And in fact, if we examine most of the things that we make today, none of them could stand alone. They all require a web of other interdependent technologies. And I began to view technology not, again, as a single standalone set of artifacts, but the way in which all these things codependent upon other technologies form kind of a super organism of technology. And I call that the Technium. So the Technium is that large system of stuff that we're making. And if you look at systems of any sort, either natural systems or the systems that we have made, all of them exhibit certain inherent tendencies. That's the nature of anything that has a recursive loop in it. And you guys are all familiar with recursive loops. So when you have a chromosome with genes, where some genes turn on these, genes A turn on genes B turn on gene C, C turns on genes D, and genes D turn on genes A. Whenever you have these recursive loops, and you have them wherever you have very large systems, you start to have these systems exhibit recurring patterns, convergent bases of attraction, things that will exhibit a certain inherent tendency in that system. And that's true from computer simulations, the internet, ecosystems, you name it. Wherever there's a very large high dimension of connectivity, we see, and recursive connection, we see these things exhibit some kind of a bias, meaning that if you run them again and again and again and again, they tend to converge on certain behaviors. So here we have a system, the technological system, and it too, because of its recursive nature and self-creation, it too exhibits certain biases. And the question I asked in this book was, what are those biases in the Technium? What are the biases in this system? If we keep running it again and again and again, if we could rerun it again and again, what are the things that would come out? Where does it tend to go? Now, one of the chapters in the book is called the Unabomber Was Right. The Unabomber was Ted Kaczynski, who was a serial murderer who was blowing up advocates of technology as his, I guess, as his rage against the Technium. He didn't call it the Technium, he called it the industrial complex of some sort. But he argued that this whole thing had an agenda, that there was an inherent agenda in the elaborate economic, technological thing that we've made. And I think he's right in that. He's wrong in that he concluded that its agenda was to rob individuals of freedom. Because in my analysis, as far as I can see, and looking at the course of it through history, the agenda of the Technium is actually to increase choices, opportunities, and freedoms for us. And so I disagree with his conclusions, but I do think he's right, and some of the other critics of technology are also right in saying, hey, this whole thing that we've made has an agenda. There are certain things it's favoring versus other things that it leans away from. And just to be clear, when I talk about the Technium having an agenda, having wants, I'm not saying that it's conscious or intelligent right now. I'm saying that it is leaning in certain directions and it has urgencies and wants and tendencies in the same way that a plant would lean towards the light. A plant wants light. It's not conscious that it wants. It's not an intelligent want. It's a survival want. It's a need. And I'm saying that the Technium as a whole, this whole complex of all these interrelated things that we've made, exhibits a want very much like a plant. So it's leaning in certain directions. And the sort of the assignment I used for this book was to try to look at the world through the eyes of technology as if it was a living organism and to see what it was that it wanted. Okay, so I can talk about what I see as those kind of trends, those long-term trends. But before I do, I again want to just put in the context of what it is. That again, yes, it's a system that has that we've made over time with several million different species of technological inventions that are all codependent on each other. But I want to put that in context of something even larger. So we ask, what is technology? What is this thing? So one of the ways I use to describe the Technium, this thing, is as the seventh kingdom of life. And I do that because the trends that I'm going to outline to you are remarkably similar to the same trends that we see in evolutionary biology. So what I'm suggesting is that in a kind of Marshall McLuhan way, which he said that the wheel is an extension of your foot, and the microphone is the extension of your ear, and the camera is an extension of the eye, and of course, the internet and Google and all those things are kind of some extension of our brain, that this Technium is in some senses an extension of the processes of life. So we know that the inherent essence of life is really not in the molecules, the wet stuff. It's much more in the informational pattern that is animating life. That's really what life is. Life is not the wet tissue. It's this process of information as it's being replicated through evolution and replicated in the genes and replicated in organisms. And it's that flow and structuring of information that really is the essence of life. And that essence of life is information. And it's basically it's information processing. We kind of understand that. But it turns out that the long-term information processing that life does is very similar to the information processing that the technology does. Okay, so that's the basic point. And kind of maybe as an example of that two-faced nature of what we're talking about, there are evolutionary programs that can actually, by evolutionary programming, I mean you take programs and you evolve them. You give a kind of a criteria for what you want to accomplish. You actually evolve the software code to accomplish that objective. And your former head of research, Nathan Myhrvold, told me, and I have to believe that's true, that parts of Microsoft Office have certain sections of code that were actually evolved rather than just programmed by humans in the same kind of method. So here you have true evolution, true biological process in a mechanical system. Now, at the same time, about 10 years ago, Alderman, the A in RSA encryption, Leo Alderman, he took some DNA in E. coli and used DNA to actually calculate a traveling salesman problem. So they had a code that would transfer numbers into genetic sequences, a one-to-one, and they used that to program a number with DNA, and they had another DNA, and they used that to actually, the DNA would self-replicate and try and match, and then they had a problem set, and they would actually evolve against that problem set to solve, and that problem set would give a DNA sequence as a solution, which they would then translate into numbers. So here was DNA doing computing. So we have computers that are doing evolution, and you have DNA computing, and you can see very clearly that there's really the same process involved. So what I'm suggesting is that in a certain sense, this, even though we think about this as it's about material science, and this is about making objects, physical objects, and we have all these wires connected, and we have these built structures that really, in the foundation, this is really much more about information processing. It's about structure. It's about the order and the structure of these things rather than the materials. And that what we're involved in is ordering and arranging these atoms with information. So if we look at the long-term history of the cosmos, start with the Big Bang, and you go forward, it's very clear that there are that the universe is running down, the entropy is increasing over time. That's the one universal law we think is true throughout everywhere in the universe. There are no exceptions that we know about. There's entropy, every process increasing entropy. But at the same time, there's portions of the universe where there's order increasing. Okay? And they start with things like a galaxy. A galaxy persists in this order. It's actually a self-organized entity that's increasing entropy around it but it is an exotropic system. It's actually building up order over time, and it's maintaining this order over billions of years as it circles around very slowly, and you have this self-organized structure, very large scale. Within that are billions of stars, and each one of those stars is also a self-sustaining, self-organized system. So it's a very complicated way. They actually generate, they go through phases, they have life cycles. They're basically engines that create heavy atoms from light atoms. And it too exhibits certain exotropic, self-sustaining, persistent equilibrial order. And around those may be planets with atmospheres that are self-sustaining and self-governing, self-maintaining. And then in at least in our corner of the universe, is life, which is itself another self-created, ongoing, increasingly ordered system. So we have, in a certain sense, we have kind of an unbroken thread back to the Big Bang of increasing order over time in the face of entropy around it. And life is the most manifest of it, and then we have our minds. And the Technium is the further evolution, the further acceleration, the next stage in that kind of ordering that follows all the way back to the Big Bang. So what that means to me is that while we think of technology as something that is actually just coming from humans, something that humans have invented, it is that, but it's also the latest iteration of a story that goes back to the Big Bang. Okay, there's a long arc of increasing order over time that the Technium is just the latest visible iteration of, and that when we kind of align ourselves with the Technium and the technology and the stuff that we make, we're actually aligning ourselves with something that goes back 3.7 billion years. It's a big story, and will go on beyond us. Okay, so that is the larger context, the larger cosmic meaning of technology. So when we are sitting in front of our computers working on the next thing, the next iteration of something, whatever it is, while it is true that we're just doing that, and maybe it's something, a game, or maybe it's a office productivity tool, whatever it is, we are actually engaged in something even bigger, I believe. And that is that we are engaged in increasing this thing, this exotropic thread of life. It's an extension of life and mind. And we are increasing what technology is bringing us, which is increased options, opportunities, freedoms, and choices. So that's what we're doing. And I think that that's important to keep in mind, because I think at times when we're involved in making these things, sometimes they don't maybe even sell, sometimes they're not ever produced. Sometimes even when they are produced, everybody has them for a while, and then they go into the next thing. I think it's very hard. Sometimes we are disheartened by that. But in fact, I think we can take a certain amount of joy in it, because we're part of something that is running through the universe and going on beyond us. It's not just making junk. It's not just making other stuff. It's actually increasing the opportunities, choices, and possible species of everything in the universe. So I think there is a positive meaning. I think there's actually a moral dimension to the technology. It's good. It's bringing us those good things. We can talk about the negative things. There is a cost to that. But I think in the end, the positive outweighs those costs, and that in the end we have, like life itself, life is a positive force, mind is a positive force, technology is a positive force in the universe, and it's the most important force here in the world. So the question I'm sure you're asking is, okay, what are all these things? What does technology want? What are these trends? Where is it going? And I'll just kind of give you some idea about those. And I would really, you guys are so smart, I really want to hear questions and learn from you. And then we can also talk about things that are going to happen, next year or next couple of years. So, well, what does it want? I already mentioned one thing. The primary thing that's moving through the universe, the primary thing that's sort of moving through technology, the Technium, is this push, this urge, this tendency, this drift towards increasing possibilities and options and choices and freedoms, freedom of actions. And every new technology, when it comes along, will create new problems. In fact, most of the problems that we're solving today in our world are technogenic. They're actually problems that have been created by previous technologies. And so there is a large amount of the consequences of technology are problems. But at the same time, what it's also giving us is choices, opportunities, and possibilities. It's sort of inhabiting or populating the universe with these new species. And one of the ways to think about technology is that it's a way for evolution, as an extension of evolution, to create species of things that the DNA tissue system could not. So one of the things that sort of technology wants, in addition to increasing choices, is it wants increasing complexity. There's a move throughout biology from the simple to the complex, and not just because that's the only direction it can go. Even when we examine things that have some complexity, things never become simpler in evolution in terms of on large scale. They don't ever devolve to simple. They always go in the other direction, even though they could become simpler. There's a long-term trend from the general to the specific. We have the first cells were general purpose, and then it became more and more specialized over time. So we have 250, in our own bodies, we have 250 different cell types. Skeletal cell, muscle cell, brain cells, bone cells, they're all different. They're all specialized cells. The same thing in technology, of course, is we invent a camera, then we specialized into underwater camera, panoramic camera. And then those panoramic may have specialized, or underwater may be the deep underwater or shallow underwater, UV underwater. So we constantly are more and more making things more and more specialized. That's the general trend. So which says, basically, you want to know where it's going? It's going to become more specialized. Whatever it is that you can imagine right now, you can imagine more specialized versions of it in the future. We go from the increasing diversity. I did a count of the number of species of things. In our household, my daughter and I counted everything in our household. We were approaching the total number of species of objects as King Henry VIII. And King Henry VIII objects, all they did an inventory when he died, and his stuff in his household basically doubled as the wealth of England. So in a certain sense, in our typical American household, we have almost as many species of things as England did several hundred years ago. But however, despite that fact, there are many things in our households that the wealth of King Henry could have never had purchased at all, like $1 worth of antibiotics, refrigeration, flush toilet, a comfortable ride of 100 miles. Those things were completely out of his reach. And so in many ways, all of us are much, much wealthier than King Henry ever was. And that's showing that the number of choices and species of stuff that we've made continues to diversify and increase. And the other trend is increasing energy density. Okay, so energy density is a very interesting thing. So I mentioned these galaxies and the stars, which are kind of self-organized. And we think of the sun as being extremely dense in energy, but actually, if we take the energy density, which is ergs per second per gram, so the amount of energy passing through per gram per second, that a sunflower is actually more energy dense than the sun is. And that's because of the longevity of the sun. And actually, technology is even more energy dense than life. And the most energy dense thing that we know about in the entire universe is basically the chip in your PC. It's sending more energy per gram per second through that than anything that we know about. And of course, that is the design challenge for PC designers, is that the thing is just going to melt or explode if you make it any more dense than it is right now. And so we see, again, that's a general trend in evolution, in cosmic evolution, is this move towards energy density, the processing of energy through a very small amount of matter and time. And another long-term one is a move to ubiquity. Things want to be ubiquitous, and one of the things I suggest about whenever we think about a new technology, the real question always is, what happens when everybody has it? What happens when it's ubiquitous? That's when the second order and third order effects kick in. You know, 1 million cell phones is interesting, you know, but 6 billion of them is an entirely different thing. You know, a million cars is interesting, but 6 billion cars is an entirely different thing. And so, so what we see is, again, is a trend towards ubiquity. That's another long-term trend. And there's also a trend towards increasing structure in emergent systems. And so, what do I mean by that? Well, in life, we went from cells, and a bunch of cells gathered together and made an organism. That organism is a new structure. So the behavior of the organism does not reside or is not captured in the individual. So I'm a beekeeper, and they can talk about the behavior of a beehive. There's nothing about the behavior of the beehive that is actually inside the bee. I mean, you look at bees, there's nothing that would ever tell you how the hive is going to behave. And so we see the same thing with technology, is that small units can coalesce into larger units, and those larger units, these new structures, have their own behavior, exhibit their own level of reality, and are an emergent level of existence. And that is also another example. We see that both in biology and technology. So those are some of the kind of trends, long-term trends of what technology wants. It wants increasing diversity, increasing complexity, increasing emergence, increasing power density, and a few other things. And those are running through this system, and they're going out beyond us. And whenever we make some new technology, we can fairly confidently bet that it's going to be more complex, not simpler. It's going to have a higher energy density. It will increase specialization, and it will have increased diversity. And all these things are trends that exist and have operated long before us and will continue long after us. So there's a lot more to say about the evidence for that, why we see trends in evolution. That's kind of a controversial idea, that actually in evolution itself we see direction and trends. And if we have these trends, that also means another significant point, which is that the sequence of technologies are inevitable. Okay, so let me say that again. It means that because there's this channeling through evolution in nature, the sequence of technological development that we see are inevitable. So the technology is coming down, the larger macro level, not the minor level, but the macro level, kind of like at the level of, say, making an internet. The internet was inevitable. We have a choice about what kind of internet we want to make. But the fact of connecting everything to everything else, that's an inevitable process that will happen basically on any planet. And it would happen again if we rewound it, no matter what political regime we were under. We're going to connect everything to everything else. That's an inevitable step in evolutionary progress. And our freedom and our choice is about what kind of internet we would make, what kind of an expression of it. And so the fact that a lot of technologies are inevitable, we should see as an opportunity, because it means that we can prepare and educate ourselves and acquire the literacy to maximize their gifts and to minimize their harm upon us. And rather than kind of run and deny and say, well, we're going to resist this as long as possible, we actually can use it to our benefit. And so one of the things we could be involved in is trying to ascertain the things, the forms, the macro forms of technological advance that are inevitable. So I think I've said enough interesting things that I like to start to have a conversation about it. And I'll start with this guy here, who, I don't know how you do this, whether you introduce your names or what, but...
They just yell out the questions usually.
Okay, we'll be anonymous then. All right, so go ahead. Yell out the
questions. All right, so just sort of spinning off of what you just said.
Right.
I think in the book you talk a little bit about the Amish.
Yes.
And how they make very considered choices about the technologies that they adopt. And so that's a little bit in contrast to the idea of technological inevitability.
Sure.
That technology is kind of rushing at us. We have no choice but to just accept it.
Sure.
In their case, it seems like they're very conscious about what technologies they accept or reject.
Yeah. So I have a great admiration for the Amish because they're not Luddites. They actually are kind of hacker types who love technology. What is special about the Amish is that while we all kind of make technological decisions about what we're going to have in our life and not have, the Amish do it collectively. So they decide as a group which technologies to embrace. And secondly, they have a very clear articulation of the criteria that they use for selecting. And that criteria is, very briefly, will this new technology help us to work at home in our backyard as a family? And does it bind our community together? So they aren't at all anti-technology. They use disposable diapers. When you go shopping with them, they've got Cheerio boxes of Cheerios and all this other kind of junk food. And they've got they use genetically modified crops. They burn a lot of diesel oil. They have solar cells, LEDs, and they seem to be adopting cell phones. But at the same time, they have horse and buggy. And they may use, and they use a lot of pneumatics. They have pneumatic air hoses to run machines and stuff instead of electricity. And they may have a diesel, they may use horses to pull their diesel-powered combine, so the horses are pulling this diesel combine. And it seems all very strange, but what they're trying to do is they discovered that the horse limits them to 15 miles. And so whenever they go shopping, it has to be locally within their community. And if they go out on a picnic on Sunday, they'll do it locally, or they can visit the sick locally. So the fact that they don't have cars forces them to maintain their community. It has nothing to do with, they're not against cars or the technology of cars. It's just that this is forcing them to develop their community or to find jobs where they can work at home. So I stayed overnight with one Amish family. They had bonnets and horse and buggy in church in the morning, but in the backyard they had a $500,000 computer-controlled milling machine that their daughter in the bonnet was running. And it's like, oh yeah, because that's good stuff, because we can work at home and it's in our backyard. And because industry is in our backyard, we keep it really clean because it's in our backyard. And so they are not adverse. And so they actually aren't resisting technology either, because in my mapping out of the Amish is that they're basically kind of like 50 or sometimes 75 years behind. They're slowly taking it, but in a very careful and judicious way. So they are, and as I said, there seem to be, some of the churches are adopting the cell phone. So when I say things are inevitable, I'm not talking about locally, I'm talking about globally. We don't have TV. Our kids grew up without TV in our house. So, in our little area, it's not inevitable. I mean, we can carve out things. I'm talking about it, and globally, that this thing in a global manner is certainly inevitable. We can all make or deny or refuse the technology locally, and that may be a good thing to do. It's not going to stop the fact that it's going to appear on a planetary scale elsewhere. In fact, that most of the prohibitions, most of the nations, in attempts to install prohibitions on technology were never successful globally. They were able to temporarily postpone the adoption in a certain small area, and that was about it. And so, yes, you can do that. You can prohibit in a certain small area, a certain locale, and that may be good for identity reasons. It may be good for the community, but it's not affecting the global adoption of things. Yeah.
What metric do you use for really looking at the rate of evolution of technology.
Yeah.
And have you compared that to the rates of genetic evolution?
Yes.
How do they compare, and is there a shape to the curve?
Yeah. So one of the ways to judge the speed of evolution in the biology world is to look at mutation rates. And what's interesting is that for a long time, biologists believed that humans, that there are biological evolution had ceased when cultural evolution took over. There was this idea that we were kind of evolving very fast, and then we have cultural evolution which takes over, and then we kind of stopped evolving. But it turns out, actually, looking at mutation rates in our DNA, that actually from the invention of civilization or so 10,000 years ago, our genes are actually now evolving faster, 100 times faster than they were 10,000 years ago. So in a certain sense, our technological innovations, lactose, when we domesticated the milking animals, we invented cooking, which changed our cooking, allowed us to digest certain things that we could not before, and that new nutrition changed the shape of our jaws and our teeth. So basically, something we invented changed our bodies permanently. We are kind of technology. We are one of the first domesticated animals ourselves. All these things show that actually the speed of change of biological evolution in humans has accelerated. So we have that measure. The measure for technological advance is a lot less agreed upon, a lot less certain. One of the proxies that people use are things like the number of inventions, the number of patents. And so that doesn't really make any sense until we have a patent office. But that is one proxy used for the speed of innovation. And that curve looks like one of those, exponential singularity curves. It's just going up very, very fast. I think, can we prove that this is happening? I mean, in information terms, I did an analysis of how much total information there is in all the genomes of all the living organisms on Earth by species, and the total amount of information that's stored on all the storage available, which is several exabytes, 20, 30 exabytes or something, and it doesn't compare. I mean, the amount of information being processed by DNA in species is much greater than what the Technium is doing. However, the thing about the Technium is that is doubling every 18 months, so it's on a Moore's law. And so while the biological processing is not processing at that speed. So we can look at a kind of a species as a information processing, and but they're just with probably 5 to 30 million different species on a planet, we're still not anywhere near the amount of processing power that biology is doing. Yeah.
So I was looking and I noticed you referenced hundreds of books for this, and you talked to a lot of interesting people. And I'm just curious, what surprised you the most?
That's a good question. That's a great question. There were several things. One, I would not have believed that technologies did not go extinct. That was a surprising finding. That actually, in the book, I talk about kind of an exercise to establish that. I took a 1894 catalog of Montgomery Ward and went through some of the pages where there was archaic farm implements, and I was looking to see how many of those I could buy brand new, not antique versions. How many of them were still making? And every single one of them was still being made. There were the things I had no idea what, like, what was it called? Corn knob shuckers or something. There were these very obscure things I couldn't believe. They're still being made brand new. And Robert Kurlwich, who is a host of Radiolab and a science journalist, I was talking to him about this, and he couldn't believe it. He says, I'm going to prove you wrong. So he actually sent 2 interns and a researcher to go through the rest of the Montgomery Ward catalog for 120 years ago to find something that was not being made new today, and they could not. He wrote me just last week saying, I think, I have to admit that I cannot find anything that they're not making new somewhere. You can buy a brand new flint antler handled knife that is made exactly the same way that knife was made 100,000 years ago. You can buy it for $50 brand new. They're still making that. There are more blacksmiths alive today than ever in history. The number of people who are knapping, they call it knapping flint. They make these little points by pressure points. There are probably more points being made now than at the time of the Indians, just in terms of the number of populations. There's weekend napping, festivals and stuff. They're generating huge amounts of these points. And what's interesting is that they cannot, even the experts can't really tell the difference between the two. So somewhere in the world, they're still making a technology that existed in the past. Things don't really go extinct, they go obsolete, which is not the same thing. So that was a surprising thing. I had no idea about that. And then the other thing that sort of surprised me was the inevitability. I didn't set off with that idea in mind. I didn't even like that idea. I mean, I found in the literature they call it technological determinism, and I thought that was, I didn't want to be one of those, but now I am. And so that idea, and I looked at prehistory at a time when there was very little communication or travel between the continents, and I looked at the sequence of inventions of technologies in like Africa, South America, North America, when there was no connection, no travel between them, and the sequence of how technologies came out was basically identical, or statistically very close to being identical, and that surprised me. I was really surprised which suggests, because simultaneous invention is the norm, and that was another surprise. I had heard about those occasional things where people invented things at the same time, but if you go into the literature, every single invention was simultaneously independently invented more than once, more than twice. So, Alexander Graham Bell submitted the patents for the telephone within 3 hours of Asher Gray. Within 3 hours, okay? And the hypodermic needle was invented 6 times. The incandescent light bulb 23 times independently. Edison was the first inventor of the light bulb. Okay, and it just goes across, and in modern times as well as ancient times. There was a study looking at, and this was a really great controlled experiment. So there's during World War II, when they were developing the atom bomb, they had lots of groups working on this, and they were separated by country, of course, and even the U.S. had 4 different teams working on it that were also separated by need to know, meaning basically they didn't know what the others were doing. And of course, within the U.S. and Britain and Germany and Japan, they didn't have any knowledge. And going through, five of those 6 teams discovered the equation for the chain reaction, or one part of that chain reaction. So independently, they all, and the reason why we know this is we have a complete record, because they're very good at record keeping. We have a complete record of them independently coming to the same invention, the same creation, invention, discovery at the same time, independently. They all did it a little differently. They all had a slightly different notation and interpretation of it, but it was the same idea done, again, absolutely 100% independent of each other without any knowledge of it at about the same time. That is the norm. And it's the norm because whenever you have all the precursor technologies sort of settled, the next adjacent step is absolutely there. It's just going to happen. It's inevitable. And the reason why we have a patent office is everybody knows that if they don't discover it today, someone else is right behind them. And that's because these things are just on a progression where it's like in ecology, you get all the other steps, this is it, that's what happens. And it happens in the arts too. Right? I go into that in my book. In the back.
I think the idea of looking at technology as a system and following the complexities and noticing biases and stuff, I think is a fantastic metaphor and a way of approaching the subject.
Yeah.
What I find challenging is the idea that it actually has an independent momentum, that it is, in some sense, a mind in its own. One of the obvious differences, at least to my mind, between that and biology is biological evolution happens independent of human agency, whereas technology really requires human agency. And to me, a lot of the examples that you bring up, particularly just now, are so related to human culture and communication and the mechanisms by which we work together. The simultaneous invention is actually a creature, as much as anything else, of having the ability to communicate ideas throughout society in different ways over a longer period of time. People are on similar pages because they can talk to one another. That's technological, but it's also cultural, and I think it's the cultural needs that really drive these things.
So what would persuade you? What kind of evidence would you need to be persuaded?
I don't know. I find it hard to imagine that technology can function independent of human agency.
So you're saying there's no I couldn't persuade, no evidence would persuade you?
To imagine what would convince me. I'm not saying that I couldn't be convinced.
Right. So I think that's the issue is that because we are involved, it seems almost definitionally impossible to satisfy that. Saying, well, that there is an aspect of this, because again, I'm not saying that there's wholly autonomous. I'm saying autonomy is sort of a continuum. It's not a binary thing. It's not like you're autonomous or not. You have increasing degrees of autonomy. So what are some of the, we have self-repair, we have self-direction, we have self-creation, there's self-governance. All these things of the self are aspects of it, and none of those are binary. So even ourselves, are we fully autonomous? Well, we have a bacteria in our gut that's we depend on to digest our food. Does that? So we know that we're not fully autonomous.
We also can't operate. We can't operate independent of a cultural
system
of other people.
Right. So if I make the claim that there's some autonomy to this, what evidence would persuade you that it was?
I guess I understand the point, and particularly when it comes to degrees. I think when it comes to the idea of technological determinism and whether you fall into that camp or not, I think one of the dangers, and I think probably where people who espouse the term technological determinism and so forth may be coming from, is that what that does is it takes the human element out of the equation to some degree or another, and makes it about a kind of machine that's just going to go on regardless. It's quite possible. There have been periods of history, and granted, you can look at it from a distance, the momentum and complexity continues, but take the Dark Ages, a massive step backwards, and there are technologies that were discovered back in classical times that we're now rediscovering, and people are going, wait a minute, actually this was done before. So there are places where the needs of human culture and the way that people interact with objects and technology go in a certain direction, and then that can get put off track. And a lot of that has to do with the way people are interacting with one another and what's going on in the economic.
So just be clear, I'm not saying that there is no human agency at all involved in it. I'm just saying that the Technium itself has an agency itself, that we're co-existing with it, we co-work with it. So we are both the creator and the created. All right? So because we have actually created humanity, it's our creation, we are the created. At the same time, it's us who created it, so we are the created. So when you have self-creation, whenever you have self-creation, you have that thing is both the created and the creator. And you have this ongoing tension between the fact that technology is selfish to some extent and also under our service. And so that tension is always going to remain as long as there is technology, which it will be in 3,000 years from now, because we cannot live without technology right now. If you stripped every bit of technology from the planet entirely, humans would die in 6 weeks. If you took all tools away, everything. We are just not capable as animals of living without technology. We are already symbiotic. We are already cyborgs in a certain sense. And because of that tension between the selfish nature and the autonomy, the small autonomy of the Technium, and our own mastery and our own ability to direct, those two will always coexist. And we'll, in the year 3000, we'll still be wrestling with the fact that we can make this stuff, but it also reacts against, it has its own response. And what I'm suggesting is that those two things, it's not as if technology only exists with its own agenda, that's all there is. I'm saying, no, it's like something that while we are creating it, it's also responding back. We make our tools, we shape our tools, the tools shape us. It's a co-evolutionary symbiotic relationship.
And I think that, I'll leave it alone and let other people go on from here, but I think that, to my mind, what you say about symbiosis is to me the key element, is that it's a way of looking at it as an extension of human culture.
Right.
And to some extent, whether or not it's completely independent is somewhat irrelevant to all the great points you make in terms of the direction that it's going, the interrelationship and the necessity of technology to human life.
Sure.
But thinking about it as an element of human culture at least allows us to put people at the center.
Yeah, well, I guess I have no. I mean, I think we normally think of it as people at the center. So I'm not I'm not sort of emphasizing that side, because that is sort of the default. People normally say, oh, we're in control. It's only making what we want. And so I'm saying, yes, that's true. We want to go a little beyond that to understand that the thing that we have made exerts its own little bit of autonomy, and that we have to kind of understand that. So in a certain sense, it's like Dawkins' selfish gene. If you just view biology entirely as the selfish gene account, you miss a lot of what biology has to offer. However, that's a very productive way to look at it. It's not the only way to look at biology, it's just the selfish gene. But it's a very productive way. And so that's what I'm trying to do right here, is say, let's look at the world through the eyes of technology itself to see what it sees through the world. So, yes?
I would compare it almost like, as I was listening to Kevin, to me, it's non-organic matter, organic matter, and then technological. So at some point, right, we used to have just non-organic chemical elements. At some point, organic life became. So to me, it's that the new point when technology, that organic life turns into the completely new types of technological matter, and then takes off its own individual.
Yeah, it's kind of, I think, of dry life.
Yeah, and my question would be, because of the speed of technology development is so much faster than biological, so what do you think the consequences are?
Yeah. So
in our lifetime, or
right, and so this is where the idea of the singularity, Ray Kurzweil and others' idea that we have this acceleration, and the acceleration is accelerating, and we have this kind of takeoff where we will produce change so fast that we cannot even see beyond it. And that, let me address a couple of things. One is, I don't believe that the framing of the singularity is actually, for me, very useful. I'm not going to, but that's a separate issue. However, the idea that we are accelerating is true, and there's undoubtedly that it's accelerating much, much faster than the human cycle can accelerate. So we may see a change, 100 years change in a year. What do we do about that? And that's a kind of a common question, and a legitimate question. If the Technium is accelerating, can we as humans even deal with that? And I think the answer, my answer, is that, like other things, the answer is more technology. The answer is that we can actually devise tools to help us dealing with the fact that things are accelerating. Okay, so an example would be, okay, you have this increasing expansion of choices. Well, you invent recommendation engines and collaborative filtering and all these things to help us deal with the fact that choices are expanding faster than we can normally handle. And if there are things that are increasing speed in other ways, we can actually invent tools to help us slow them down, to help us match the rhythm of our own selves. So in general, I subscribe to the idea that the solution to any problem, even a technogenic problem, is more technology. Just as I would say to you that if somebody was spouting some really stupid ideas, your response should not be to think less, but to think more and to have better ideas. And so the response to the problems caused by technology is not less technology, but better technology. And the response to the kind of the problems generated by the acceleration of change is not less, but to actually make tools and technologies that can solve those problems. And I believe we can do that. Yeah?
A little bit about what you think some of the drivers of technology are. What drives technological change? Because technology is really reflected in how we see the world.
Yeah, so
I mean, the notion of technology is really defined through the human psyche.
So what drives technology? And I'm suggesting, in a very strong way, that the drivers of technology are the same drivers that propel evolution through 4.4 billion years of life. That there is an exotropic, self-organizing bias in the universe that is moving, that we're connected to, that's moving through the galaxies and the stars and through life itself, and is pushing through the Technium.
Does that mean that technology is independent of human evolution?
Yes. In other words, am I saying that technology might occur in other planets in the galaxies? Yes.
Would it look at all the same?
Yes, it would. And that's the remarkable thing. And I'm saying that there are constraints. There are channels.
Constraints.
What?
The constraints of the physical world?
That's the one. There's two constraints. There's the constraints of the physics and chemistry that also work on evolution, that narrow evolution through certain channels, saying evolution can't produce any possible thing. It has to be bound by the fact that cells are three-dimensional and have water weights and all this kind of stuff. So yes, there's a physical thing that constrains evolution and technology, and there's internal constraints. These are internal. I talked about them earlier. The recursive nature, when you have these networks that are recursive and that are very highly interdependent, that you get constraints and recurring patterns.
Can you give an example of that where you think it doesn't really act as a reflection of the way the human organism works?
Okay, so let's start in biology. In biology, they have something called convergent evolution, which means that you have the similar structures that occur, like for instance, flapping membrane wings, in four different, very, very different, pterodactyls and bats and birds and there's another one I forget. And eyeballs and eyes independently arose multiple times, 30 different types of eyes, 3 different types of camera type eyes throughout evolution, venomous stingers. There's a long, long list of all these things that, again, that evolution kind of keeps coming back to again and again. And I would say in technological evolution, I was just giving you the example of the prehistoric parallel sequences of technological inventions on different continents that weren't connected together. And I would say simultaneous invention. Now, someone else would say, well, if humans were involved in simultaneous, how do we subtract it out? So as long as humans are involved in technology, how can we prove that there's any kind of inherent biases in it? So all I can say is, tell me what kind of evidence would persuade you, and I'll provide the evidence.
I'm going to be persuaded because I think it's really the blending of
right.
rules of the physical world and the structure of the way human beings see and interact in that world.
Sure.
That part of it.
Yeah, right. And so
I need a separate entity, right? Separate organizational entity.
Yeah, so the separate continents was one experiment where they were separated. Those were separate. That's kind of a control thing. So until we have, say, another world where there's an entire civilization going on in parallel, it may be very difficult to convince the most skeptical person. So we have on life. Here's the problem with the studies of evolution. We have a case example of one. There's one life on Earth, only one. So whenever you try to look at something with evolution, it's really difficult. However, Stephen Jay Gould, who claimed that there was no direction in evolution, said we can't rewind the tape of life. However, we are able to do that. There are experiments with bacterium. They take a sequence of the bacterium, and they make clones of the same bacterium, so they're absolutely identical genetically. They set them in these very controlled containers that have absolute uniformity, and they can find that the same kinds of sequences will be evolved in 4,000, 5,000, 10,000 generations later. Okay? So there actually is channeling happening in biological evolution. Okay, so now, if we could do that experiment in the Technium, if we could run parallel, as far as I could see, every example where I could see of independent parallel work, the kind I just showed you about the development of the H-bomb, they were completely independent and parallel. The advance of invention in prehistory on independent parallel continents always shows that the same things come again. So so that's my suggestion. Yeah.
So, I'm not sure quite how to phrase this question, but
Take your time.
Okay. I'd like you to comment about the force of choice.
Yeah.
And you've used the term like exotropic
Right.
force in the universe, and you've defined some of the, I forget the term you used, but some of the trains that are associated with 7 different forces of this, that guide biological evolution. But somewhere in there's this concept of choice. And,
Sure.
And when I say the word choice, I mean it at a very kind of fundamental level. Like, and I get into this discussion often with people where, let me just give a brief example where, like there's a rabbit on the side of the road, and you're driving at night, and you see the rabbit, and does that rabbit have a choice of whether to cross the road and potentially get hit or not? Right? And I maintain that it does.
Right.
Right? People choose whether the Democrats or Republicans. I maintain that being gay is a choice. I think for me, choice defines defines how we interact with the world.
Sure.
And I'm kind of associating that term choice with this exotropic force.
Yes.
But at the same time, I think what you were just introducing was that there isn't choice, that it's predictable. So,
Right.
Again, not sure.
Sure, yeah, actually, I deal with this. Let me say several things about choice and free will. There's a great conundrum in physics, in quantum physics, about the decay of particles. And John Conway, the guy who invented the cellular automata, game of life, a mathematician, did a great paper recently where they examined the decay of spin particles and other quantum particles. And they said that from their analysis, this is definitely not a predictable, it's not predictable. It's not like kind of the two-way work that most physics go. They're reversible. It's not that. It's not random from their analysis of how these things happen. They're not random. They actually said the only explanation they could come up with is that these particles actually were choosing, was a free will choice, whether to decay or not, and that free will was actually the foundation of all the higher free wills in our own organisms. And I think that, in fact, one of the trends in technology is increasing the space for freedom of choices. It's actually increasing free will in that sense. And so how does that square with our talk of inevitability? Because, in fact, what I'm suggesting is that there are kind of bottlenecks in which things go through, but that going through them is inevitable. So in a certain sense, life is inevitable, but it may not. But it may be. It's sort of like it's an improbable inevitability, if you can understand that. So what's happening with life is that the more variety there are, the more improbable a particular species is. The more highly evolved it is, the more improbable it is. But it's also inevitable that there be some, when the right conditions are present, the occurrence of life or whatever it is inevitable. So we have both of those things operating at the same time. We have the fact that when you have made something, you constrain where the future of that evolution will happen. The more further along you go, the more improbable, statistically that is. That's the definition of exotropy. It's improbable, okay? That's the relationship between information and entropy. And so the more highly evolved something is, the more improbable it is, but at the same time, the more inevitable it is that something will go through that bottleneck, because it's channeled. You can't be everything. So I spend some time in the book talking about DNA. Let me just give you an example. So DNA, so scientists took a whole survey of all the different kinds of molecules that might do the same thing that DNA does. And what they discovered, in fact, was that there are very few that could do that. But we could imagine other alternative processes to DNA we can make with our mind. But what we have not been able to find is a molecule that could self-assemble and do all those things at the same time. So it may very well be that there's only a few molecules in the entire universe that can both do everything the DNA does and create itself. So, a lot of biologists and some astrophysicists think that in other galaxies and other places where there is life-like things, that those molecules will be DNA-ish, that it's the most remarkable molecule in the universe. It could be that we have a lack of imagination. We just can't imagine it. We could certainly imagine other kinds of molecules that could do all the things that we could invent that might do what DNA does. But finding one that could make itself, there may only be one or two. And so in that sense, while life may be inevitable around the world, it may have to go through a very narrow few molecules to do it. And that's the kind of thing I'm talking about.
And maybe one more question
Yes.
that everyone else.
So you've been quiet up to now.
So are you in any way trying to marry the sort of rational scientific method into some extent with notions of like destiny and spirituality in a very benevolent fashion versus, say, evolution versus, generally there has been rationalism versus irrationalism. So there's a lot of what you're saying seems to be a very sort of benevolent way of looking at spirituality and destiny as well.
So I'm not suggesting about supernatural forces, first of all. I'm really trying to say that these are all not supernatural forces, that these are measurable, quantifiable, falsifiable forces at work. When I talk about the esotropic force, it's quantifiable. We don't really know what it is. We actually don't even know what information is. I mean, part of it, we have to actually have some better definitions of information, but I think it's an information-based thing. In that sense, the information is sort of spiritual, yes, I would say yes. It's spiritual in the way that information might be spiritual, in the sense that it's intangible, it's a force, we don't know what it is, it has some power. But I am suggesting, though, that we can see this as an alternative story. We can see this as a grand story in the universe that does have a moral dimension, that does have a direction. And I think if people find that spiritual, I think that's fine. But I think it can represent the same kind of a thing. So that was a really great last question. I thank everybody for your attention, for hanging out this time. I guess I'm going to...